Number 4. One of the electron transitions in a hydrogen atom produces infrared light and a wavelength of 746.4 nanometers. What is the amount of energy, what amount of energy causes this transition? Okay? And so I hope you notice a close similarity to what's being asked of us in number 4, number 3. We're being given a wavelength, right? Wavelength, 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 and we're being asked for energy, energy, energy. I hope you see that. Again, one of the goals of this worksheet is to help you compartmentalize what you know and what you don't know. Transitions, maybe you don't remember that the energy of a photon is associated with the transition of an electron within the hydrogen atom. Maybe you have no idea what infrared light is, and you don't know that its wavelength is about this. That's fine. It doesn't matter. It doesn't affect your ability to use these two equations to calculate your value. Now, the only thing that I think should mess you up in this equation is if you take this wavelength and immediately plug it into this value for lambda. Why? Because the units right here on this wavelength are nanometers. Realize when we calculate a wavelength, a frequency, and we're going to use wavelength, we have to cancel out that meters in the speed of light, the meters per second. Notice that nanometers, because nm, can't cancel out meters. It has to be in meters. Now, it's not very difficult. All you have to do, because that nano represents times 10 to the negative 9th, all I need to do is take this exact value right there and slap it times 10 to the negative 9th on the back of it. That's it. Now it's in meters. So, using the same strategy I did in number 3, I'm going to rearrange this equation, right, and solve for frequency. Now, once I have frequency, I can plug that frequency in right there and solve for energy. So, here's my frequency, speed of light over lambda. Speed of light is a constant. It's written at the top of the page if you forgot what it is. And here's the value that the question actually gave me. Some simple calculations, or using the calculator, I should say, some simple calculator work tells me that the frequency is 4.02 times 10 to the 14th per second. This is not the final answer, however. I need to plug that into this value for nu. So I'll do that right here. E is equal to h nu. H is Planck's constant. That doesn't change. It's at the top of the page if you forget what it is. And then slide this value for frequency in for our value for nu right here. Multiplying these two values together with some proper calculator work and remembering what you should do when you're multiplying numbers with units. Sticky note is fighting me here. You get 2.67 times 10 to the negative 19th joules.